Welcome everyone to Happy Maths Hour today. To bet or not to bet? That is the question. Well, I know the answer, and hopefully you'll know it by the end of the session.
Okay.
Good afternoon, Toni.
We're going to sort of dip our toes into the gambling waters today, but we're not going to be gambling. We're just going to be talking about it, which is very safe, isn't it, Caroline? Okay.
Yeah.
So, the National Lottery is a huge attraction, and the number of people in many countries who are buying lottery tickets is huge, and it's increasing, and the chances of winning are almost negligible. But Caroline pointed out to me about charities, didn't you, Caroline?
Yeah. So there's some gambling. It's just little things you get at Christmas, and you buy 5 tickets, and some people win and some people don't. Thank you, raffles. But the National Lottery, certainly in the UK and in Spain, is the Once, which is for blind people, and it's actually how they fund. At least certainly in the olden days, and presumably still now, it's you when you buying your ticket, you're actually making a donation to people who have no sight or have difficulty with sight. So that's what I do. Well, actually, I've never bought a lottery ticket, but if I were to buy a lottery ticket in the UK, it funds the arts. So friends of mine who do their theatre productions, thanks to the lottery fund.
Well, that's true. It does do some good, but actually there's a company that run it that make a huge profit out of it, and then there is some money that goes to charity. So let's just play this video. And can you see the video?
No.
I'm
right.
sorry.
So give me. Is that the link that you were talking about?
Yes. Can you play
right,
it,
let me do that then. Yes, let me do that, and I will play the video. Sorry, Toni, I hadn't realised that that's what you wanted to do.
Yes.
I'm on it.
Well, Caroline's going to play us this. I'd like to say that our National Lottery in the UK has got a page which is about responsible play, and we're well aware, and what we're going to be looking at this afternoon is that some people get addicted to gambling, and many people suffer because of that one way or another. Their families, maybe they're spending money on, and they're not very well off, and they're spending money that the family actually need to live, and that's getting spent on gambling. So it's not just the people who are addicted. In fact, it's often other people. And of course, associated with gambling is a lot of crime. So it's, in general, there are very big issues. But people can do a little bit of gambling, and that's quite harmless. As Caroline mentioned, just buying a raffle ticket is gambling, but it is quite harmless. Caroline, can you play us?
Yes. No, I was looking on the wrong link. Now I've got the correct link. I'm going to do that now, and now that one and that one. Okay. It's quite interesting doing all these things, being the technical person in the background and in the foreground. Share screen. Audio. And I'm just going to start it again.
Games of chance can be fun, and each national.
Here we go. Can you see it, Toni?
Yes.
Good.
Lots of people enjoy playing National Lottery games, but do you ever wonder how they work? Every National Lottery game is different, from games where random numbers create winners to scratch cards. online instant win games where you can win instant prizes. Games of chance can be fun, and each national lottery game has its own specific odds of winning. But what are odds? Odds are the likelihood of you winning a prize. The odds in games like Set for Life and Lotto are determined by the number of balls in the machine and the chance that numbers you have chosen, or on your lucky dip, are drawn. For scratch cards and instant win games, the outcome is predetermined before you play, and the overall odds show the likelihood that the scratch card or instant win game will result in a prize. The odds remain the same each time you play that game. The chance of you winning does not increase if you play the same game more than once or several times in a row. The specific odds for games like Lotto, Euro Millions, and Set for Life can be found in the Player's Guide, which is available on our website and at National Lottery retailers. You'll find the odds for each scratch card game printed on the back of the card. And for instant win games, you can see the overall odds displayed via the app or website before you play a game. But are there ways to increase your chances of winning? Whether you're using your favourite numbers, like your house number or birthday, or go for a lucky dip, your chances of winning will always be the same. Results in games like Lotto, Euro Millions, and Set for Life are completely random, and there are no predictable patterns for a winning combination. And wherever you buy a ticket through the app, website, or in-store, you're in the draw and have the same chance of winning. For instant win games and scratch cards, make sure you follow the instructions on how to play. If you want to reveal your symbols in a certain order, or use your lucky coin to scratch your scratch card, you go do your thing, but it won't influence the outcome. And remember, revealing 2 matching symbols on a scratch card or instant win game is fun, but not a sign you're about to win. You can find more information on healthy play by searching Green Big, Play Small, or following the links on our website.
Great. So what is gambling? It's an activity where 2 or more parties place at risk something of value. Those are the stakes. And you do this in the hope of winning something of greater value, which is the prize. And where the result depends on the outcome of events that's unknown to the participants at the time of the bet. So what does that mean? Okay. Well, according to the North American Foundation for Gambling Addiction, gambling worldwide has increased greatly over recent years. And this makes, this is pretty obvious, really, due to internet technology. So lots of people are gambling online, gambling on their phones. And there's a corresponding...
It's very insidious. So what they're doing is that they are sending adverts, putting out adverts all over the place, and you get to gamble for free. Have the first one on us. And it's like the drug dealer. Yes, here's one. Have a test at this. Have a taste, and they know that if they give you one for free, you might come back and get, very likely to come back and get more if you're inclined to want some. And the gambling people are doing exactly the same thing. And the addiction is
they want to get addiction. You hooked, don't they?
They want to get you literally hooked. They get, and it's even more so with the gambling, because they reel you in. They give you one for free. And then they know it. They have an algorithm that they use. Do this, then you do that, do the other, and then they'll be in the club. And they literally reel you in like a big fish. And so don't do it. Basically, don't do it.
What we should consider is that commercial gambling operations typically depend on mathematical facts which ensure that the company cannot lose in the long run. They know they cannot lose, okay? And this is different from, for example, the stock exchange and insurance policies, okay? Because there's calculated probabilities in those cases, but particularly when it comes to insurance policies. But the insurance company can lose in a freak year, for example, when there are lots of storms and floods and lots of damage. House insurance will actually cost the company a lot more. Okay, so your premiums are likely to go up the following year, but in the year when you have these unusual events, the insurance company will have a bad year. But that's very different from betting shops and casinos and organizations that run online gambling, because they have worked it all out. They have done their maths, okay? And they know that they can't lose in the long run, even, short and medium term. They're going to win, okay? And the companies are not in fact gambling, because if you look to the bullet points at the top, they're not taking any risk. It's only the customers that are taking a risk. So, well, we have to bear that in mind, I think. And we're going to look at some of that mathematics. So before we do, let's just think about some of the ways in which people gamble. So there's a lot of gambling on sport with things like football pools. And in many countries, particularly India and Pakistan, but other countries, people gamble on cricket. Okay. And what you see in the, apart from the horse racing there, you see a tic-tac man there on the field with people around and behind him. And what he's signaling with these sort of signals is sending signals to communicate to the bookies who are taking the bets what the odds are. And he's hearing, as he's on the field, he's hearing also, he's getting information, and he's passing that information to the bookie, and the bookie is adjusting the odds as before the race, so that he thinks, have a better chance of winning, and the people who are putting money on the horses are more likely to lose.
So that's called a tic-tac man. I had no idea.
Yes. And so you've got in the middle at the top there, this rather palatial looking place with lovely mountains in the background. And it's called Sun City. Okay. And it's a very big attraction, both to people. It's in South Africa. It's a very big attraction to people in South Africa, but also to foreigners going there, because it's a luxury hotel as well as a casino, surrounded by, you can go on a safari, and then you can come home in the evening and gamble. Okay. So that's Sun City.
That's better than Las Vegas. You don't go on safari, you just go and gamble.
Yes, because that's surrounded by desert, which isn't very attractive particularly, and it's a long way from anywhere. So also in that collection of pictures, you've got people playing on slot machines. Now, they're very addictive under the horses there. They are extremely addictive and very popular, and people can spend most of their time and all their money on the slot machines. In the middle there, you've got a bingo hall. Now, that is much more, in a way, sort of a gentler sort of activity. People are often people who are quite lonely, elderly people often, and it's a social activity for them. So they may pay a little bit at the door to go in, and then they may win, but they're not going to lose a lot of money.
With bingo, people schedule it. It's part of their entertainment. It's like it's going to the pub for a pint. Well, it doesn't cost them as much. They just have a cup of tea. So it's just a cost for entertainment, really. Once in a while, they might win something.
Yes, but it can be something that becomes more serious if you have to pay to play. You can play bingo online, for example, and every time you play, you pay, and if you lose very often, then it's going to cost you quite a bit if you keep playing.
Yeah.
So
so that's hence going back to the online thing, because the things, if you're going to the bingo club, there is a limit to how much you basically you pay
absolutely.
to play, but it's very
a fixed
much
amount,
limited.
and it's not going to
So
at the bottom there you see a lottery ticket, and I think that one's for Euro Millions, but they're all quite similar. When you buy your ticket, you get some numbers, and numbers may be lucky numbers. You may win, or more likely you'll lose. But this person's got number 2, number 6, 32, 37, and 43. I think it's a bit blurred. Now, up the top right, you've got a machine that's used for those balls have got numbers on them, and they are drop down slots at the top. You see those 8 slots. They're dropped down, and they drop into the disc, which is rotating, and a few balls drop out of the bottom, and they are the winning balls. And in many lotteries around the world, there are 49 balls, 49 numbers, and 6 balls. 6 are winning balls, usually once a week. And then anybody who gets all 6 balls right, their ticket has got the right 6 numbers on, they would win one of the huge prizes with lots of money. And of course, there are some smaller prizes as well. Underneath that, you'll see Casino Online. That's just a little picture indicating that you can play a lot of the card games and dice games and things like roulette. You can play those online, and even on the picture on the left is showing you can even do this on your phone. So that's made gambling a lot easier for people than it used to be. Okay, so
Toni, I've uploaded. One second, I'm just going to show the Tic Tac Man, because I didn't even notice that picture. It's so small. This is the Tic Tac Man, actually showing you an example of the signals that you were talking about.
Yes, exactly.
Yeah,
my Tic Tac Man is that one is somewhere where there are no crowds around him. My Tic Tac Man is watching the races, and he's in the middle of lots of other people. It is small, yes. Okay, so thank you, Caroline. We're going to go on to look at lucky numbers games. Now, these are really simple games, and they are along the same lines as the National Lottery, but instead of having 49 numbers, there's only a few. And we can start off, these are 4 games that we can look at, different games. So we can start off with a 1 in 4 game. And we can spin the spinner. There it is, just a paper clip on a pin, and that will land on one of the 4 numbers. Everybody can have pick a card, and then you put the card back in the hat, and everybody gets a number, and then you spin the spinner, and people win a point if their number comes up. Or you could actually have 4 people playing, and each person gets a number, 1, 2, 3, or 4, and only one person wins. So I think it's very, very easy for anybody to understand that they have a 1 in 4 chance of winning.
Yeah, and it's easy, as you say, for a young child to get that. It's a nice place to start. Am I going to get number 1, 2, 3, or 4? And they'll slowly get to realise that they'll get a 4 every once in a while. It won't be every time.
Yes, and so what we have there is a gentle introduction to probability, really. That's
yeah, so which is what this is actually all about.
Yes. So then when we come to the 1 in 6 game, it's the same thing. It's only one winning number. You spin the spinner, and you win 1 time in 6. Now, there's 2 more games described here, where you need a set of 6 cards, and one is a very simple game of 2 in 6. So you only have 2 winning numbers, and the other is a 3 in 6. So with the 2 in 6 game, you have 2 spins, and then if you have got the right 2 numbers, you win the big prize. And with the 3 in 6 game, you have 3 spins, and we're going to ask what's your chance of winning. So we're going to talk a bit more about that, but that's a summary of the 4 games. So here is the game for very young players. They take a number card from the bag and put it back. And if there are more players, everybody takes a card. So everybody's got a number. And then spin the spinner and choose the winning number. And if it lands exactly on a line, of course, we spin it again. And in this game, you record 1 point for a win. Anybody who wins gets a point, because 2 people might have the same number. And the match ends when someone reaches a total score of 10 points. So that's quite a nice game, with repeating this. So it's not just a one spin, that's the game. It's repeating it that makes it seem like a game that's let's try again. Next time I might be the first to get 10 points, So bearing in mind that the National Lottery is 6 balls out of 49, what about lucky numbers? This is 3 balls or 3 numbers out of 6. And when you play this game, you get a ticket with 3 numbers on it, and you win a prize if your 3 numbers match the 3 numbers chosen on the balls, the lucky numbers. So we're asking, what's your chance of winning a prize? And we're going to work that out together. So this is a game, right? 3 are chosen at the same time at random from the 6 numbers in no special order. And when you play this game, we'll see, are you going to win? Are you going to lose? We're going to work out the probabilities. And if we find it difficult, then if you're a teacher find it difficult, then you can do an even simpler case with 2 balls, which we just talked about. And what we will do is to show that if we have 2 balls, the probability of winning the big prize is 1 in 15. So that means that for every 15 times we play, we'd expect to win once. And there's a question here which we're going to answer. If 100 people play and they pay 10 rand, that's a currency in South Africa. They pay 10 rand, you can think of $10 if you like, and play the 3-number game, and the prize they win is 150 rand. So for 10 rand, they're going to get 150 rand. They might think, wow, that's a good prize. I want to win. Would the organisers of this game expect to make it a profit? And if so, why, and how much would their profit be?
What if all 100 people won, in which case they'd all get 150 rand? So this is about statistics. What is the probability that would happen? It's a game of probabilities, isn't it?
Yes. So let's play it, Caroline. Haven't you got your hat and some numbers?
I've got my hat.
So we haven't got balls. We've got numbers. So yep. Caroline, I'm going to choose the odd numbers. I'm going to choose 1, 3, 5, and you have to.
I'm choosing. Oddly,
you don't have to choose this. You can choose some of the same numbers as me and some different if you want to.
I just chose my numbers, and my numbers happen to be 2, 3, and 5, which just happens
2, 3, and 5.
Yeah.
Okay. I chose 1, 3, and 5, and Caroline chose 2. Let's see if either of us is a winner.
3. Is it the right way round?
Yes, you had it right way
4.
around first.
Oh, I did. Good. 4. And
neither of us is a winner.
Well, that's
5.
Interesting.
So we've got 2 out of. We both got 2 out of 3. Okay.
And we also got, what's the probability of getting 3, 4, 5 in a sequence? Okay.
So neither of us actually won the big prize, but
I get to get 2 out of my 3 numbers.
So did I. Yes, I got. Yeah. So, but the thing about it is that in the enormous lottery, we would have had less chance of getting two numbers right. But on the other hand, there would have been a little prize if we'd got, say, 5 out of the 6. I don't think we get anything for 2 out of the 6, but we might.
I doubt it. Yeah, I doubt it very much. They wouldn't make
Let's
any
see if
money
we can
then.
answer the rest of the questions that we just asked. In particular, what's the probability of us winning? And with this 3 numbers game, which is what we've been playing, and if 100 people play and pay £10 and the prize is 150, would the organizer of the game expect to make a profit? Okay, so if we think, well, let's take it to even simpler game, and let's see what happens if it's only 2 lucky numbers in 6, and the order in which they picked out of the hat. Actually, they should all come out simultaneously. So whether it's 1 and then 2, or 2 and then 1, they should be brought out together. But I have to.
Oh, I did it wrong, did I?
No, it doesn't matter, Caroline. The point is, if we didn't put them back, that was the point. But if you'd picked out 3 and just showed us the 3, that's effectively what happens with a game like this, a lottery game. So, but I have to write them down one after the other. So whether I write 1 and then 2, or 2 and then 1, it's the same choice. So I'm going to ask you to think how we might record and be sure we're going to record all of them.
Okay.
So what
For
do you think,
2.
Caroline? If we're going to make it systematic so we know we've got them all, a
Well,
neat
we
way.
start with all the possibilities. When you pick out a 1, write down all the possibilities that include a 1, and start in numerical order. So start with 1 and 2, and then 1 and 3. So then you know.
That sounds like a really neat way to do it. And then how should you proceed from there, do you think?
Well, you've already got all the 1s with 1, so then you start with 2. But you don't need 2 1 because you've already got 2 1. So that the next one would be 2 3, and all the ones above it. As you
right. So what Caroline said was the first row. So you've got 1 in combination with the other 5 numbers. And then she said, well, now you've got, what about with 2? Well, you've already had 2 with 1, so you don't need to list it again. But you've got 2 with 3, 2 with 4, 2 with 5, and 2 with 6. And then on the third row, you have the list of the combinations with 3 that you haven't had already, and then with 4, and then with 5. And if you count those, you get 15 altogether. So the chance of getting a winner now is 1 in 15. So effectively, if you played this game 15 times, you'd win once. And what we've not,
the probability, but you might win several times just because of a fluke.
Well, yes. I mean, it doesn't mean you're certainly going to win. You could play for 100 times and not have any wins. You know, it's a bit like when I not very long ago there was a flood. It didn't affect my house, but it affected my neighbors, and there was, you know, they were coming up our road in boats. I mean, it wasn't funny. My house was a little bit above the water level, and then there was another flood about 10 years later. And some of these houses were flooded twice and made 2 claims on their insurance. Now, what the water authorities do, they have flood control and all sorts. They take measures on the basis that there's going to be a flood every 40 years, and basically they don't go to the expense of guarding against that. That's the sort of that's the flood defences are built on that basis. But there should be 2 floods in 10 years instead of 1 in 40 years is extraordinary, and that can happen. You know, so whatever the problem, as Caroline's pointing out, it's in the long run, these averages work out, but in a very short time, you can get very odd things happening. Now, if we think of all the possible outcomes for 3 numbers, how would we list them systematically so we know we've found all the possibilities, as we have done with 2 numbers? So the answer is that it's very... Oh, okay, well, we'll come on to that. But I'm going to we're going to talk about tree diagrams. Do you like tree diagrams, Caroline?
I like the fact that you really can see that you've got it all. They're very satisfying.
We're going to talk about the tree diagram for 2 balls from 6. And then we're going to go, remembering what we did for 2 balls, we're going to go on and look at it for 3 balls from 6. Now, as Caroline says, this gives you a picture of all the possibilities. So the first time, you can think about either your first number matches or it doesn't match. And then what are the probabilities that it matches? And remember that in this, there is 2 lucky balls in those 6. And then once you've had your think about the first ball, or the ball you've got in your left hand, what about the ball you've got in your right hand? Or your number, does that match or does it not match? And so you're going to put probabilities on those branches and then work out in the end what all the different possibilities are and what the probabilities or chances related to those different possibilities. So let's think about that. So using the top branch of the tree diagram, there are 2 lucky balls out of the 6. So with your first ball, you've got a chance of 2 in 6 that it's going to be a lucky ball. And if your first ball is lucky, what about the other one? Now, the first ball is going to be a lucky ball with a probability of 2 in 6. But now there are only 5 balls left to choose from. And one of them is lucky. So the probability your second ball is lucky, given the first one was, is a 5th. So multiply those probabilities together. And so what it means is that 1 in 5 of the times that your first ball was lucky, your second ball will also be lucky, giving you a probability of 2 in 30, which is 1 in 15. And if we see the other numbers on the branches of the tree, you'll see if your first number was matching, so it was a lucky number, and then there are 5 balls left to choose from, the numbers to choose from, and 4 of them won't match. They won't be, yours won't be lucky. So your second number doesn't match with a probability of 4/5, and taking those 2 together, first one matches and your second one doesn't, that's 8 over 30 or 4 out of 15 altogether.
You've really got to stay very, very aware of what's happening before to really think carefully about what happens at the second stage and how many possibilities you have left, what the total is, and how many of each category you have. Unlike heads or tails or throwing a dice, where every time you throw you have all the possibilities. In this case, the possibilities go down because you're taking it out of the hat and you're not putting it back in.
Yeah.
If you would put it back in the hat, it would be a different.
It would be the same as in the first instance, yes. So what's happening here is that each branch shows you what's each stage, and then we've got 4 ways to go, and we've got 4 combinations of things that can happen. And as Caroline points out, the second draw depends on what happened with the second number. It depends on what happened with the first number. So if you didn't get a match on the first number, which happens with probability 4/6, but you do, and there are 2 lucky numbers left, so you still have 2 out of 5 chances on the second draw, and that gives you 8 out of 30 again, which is 4 out of 15. And of course, you can be none of the numbers, 4 out of 6 times, is a probability of 4 out of 6 times 3 out of 5, which gives you, and because all the others are in 15ths, I've got that as 12 over what is it? 12 over 30. 12 over 30 is 6 over 15. I haven't cancelled it right down. I've made sure they're all out of 15. Okay, so if you add them up, the chances are 1 in 15, 4 and 4 at 15, so that all adds up to 9 out of 15. 9 and 6 add up to 15. So they all add up to a probability of 1. So we've taken care of all the possible things that can happen with the tree diagram. Now, the tree diagram is very, very key, important, powerful. And even though you wouldn't want to go on going the next branches and then the one and drawing the whole thing, it's that reasoning which is you can apply without actually drawing the diagram once you understand the process. So then we're going to go.
Which helps a lot if you've got 50 possibilities with your lottery balls.
Yes. So with lottery, it's 49 balls in many countries, but South Africa have got 52, one for every week of the year. 52 balls in their lottery with 6 winners, actually. So all the possible outcomes for 3 numbers chosen from 6. So can we list those possibilities in the same way as we did with 2? And so this is a bit more complicated, but I think you can see that the first, these are all triples of numbers, not pairs of numbers. And we've listed on the top line all the triples in which 1 occurs.
I like the fact, yeah, but it's not what you've done.
In the
is you've got on the
block.
top line, in the first block, it's all the ones with 1, but on the first line, it's all the ones with 1 and 2. On the second line, it's that they all include 3, and on the second number is 3. Well, and I think that's
careful, Caroline. There is a pattern there, but the first block, the first triangle, is all the numbers with 1 and 2 other numbers. Right?
But the fact that you've written, I've written these a number of times myself, and I've never done it in the way that you've done it, where each line you're bringing it down to the next line, so it's a lot clearer the way you've done it. Because if you look, the second number, Caroline, in the second line is always 3.
The second number, that's right, because you
the
said
second
2
number.
last time.
The second number in the second line is 3. The second number in the third line is 4. So you've done all the numbers where the second number is 3, or where there is a 3. You've finished with the number 3 after you've finished with the second line, and I think that's extremely well. No, you haven't quite. It's the point is there's a system to it, and you can and it helps you make sure you found all of them.
And the other way of looking at this system, and this is important, look at this system in different ways and make sure that it really does get them all. And what I'd like to say is that in the first block, which is a triangle, that's all the possibilities of one of the numbers being 1 with all the combinations that you can put with 1. And in the middle block, that's all the combinations with 2 and 2 different numbers. And
without
then
the 1. Yeah. You no longer need the 1 because you've finished with the 1. You finished with the 1 because it's all there. Yeah.
Exactly. And in the middle block, again, it's a triangle. And it's the same sort of reasoning as we used when we were only looking at 2 numbers. And then in the third block, we've got everything possible for 1 and 2. And so this starts on the third line, as Caroline has pointed out. And in that block of, which is again a triangle of 3, we've got all of the remaining numbers in which 3 occurs with another pair of numbers. And then in the last block, there's only 1 possibility. And here we don't need to we won't have a 1, 2, or 3 in it. And therefore, the only one that's going to be there is with the numbers 4, 5, and 6 in that triple. And if you count how many there are there, it's 20 altogether. So I think that's is it? Yes, it's 20, and it's systematic, and the being systematic is important in making that list. However, I wouldn't like to list all the possibilities of 6 chosen from 49. Would you, Caroline?
I would definitely not. Definitely.
No,
I mean,
no.
you'd
So
have to write all those. I mean, the first, I don't know how many brackets would include 49 numbers.
Yes.
Like, oh.
And so we really need to look for a better method, because, well, this is very good for small numbers, but we need to look at a more powerful method when it comes to very big numbers like the lottery. And so what I suggested a few minutes ago was we should look to this tree diagram idea. Anyway, one of these person numbers must be the winning combination. So there's a 1 in 20 chance of winning. And if 100 people pay £10 to play the game, then okay, so they're going to, all the money that the person organizing this gets is £1,000. Okay. Now the expectation is that only 1 in 20 of the players would actually win, so that there would be 5 winners. Now we know, as Caroline said, sometimes there would be more than 5 and sometimes fewer than 5. But on average,
it's really a game of averages, and that's what the people that make the money from gambling know. That it's just statistics. It's just a numbers game, and on average, they will. Yeah.
And so what happens with people who are gambling? They have a lucky streak, they call it. Oh, my luck's in today, and they win a few successive wins on a slot machine or one of the games in a casino or online, and they carry on gambling because they think they're having a lucky streak. But of course, that's nonsense. The rules behind it all will come into play. The maths will come into its own, and in fact, over a period, they won't increase their chances. So that it's knowing when to stop that is, the wise thing to do. So there'll be 5 winners of 150. So the payout would be 750 rand. So the organizers would collect £1,000, pay out 750, and on average, they would make 250 rand each time. Okay, so that just a little calculation shows you how the profits pan out. But with more balls in the lotto, there are going to be bigger profits.
Yes, we need much bigger profits, and we also need a better way of working it out. Oh, what's this, Toni?
Well, you can see on the left what we showed before, which we talked about, and that was where we were looking at the 2 numbers in 6. Okay, and that's exactly what we discussed earlier. You check your first number. What's the probability it matches one of the winning numbers? And then you check your second number. Can you complete the tree diagram? Well, there it is. It's completed. Now then, what about if there were actually 3 numbers in the game?
Okay.
Now, we actually don't need to draw the complete tree diagram. We can imagine it. Okay. And there it is as a tree diagram, but with the branches for the third, when I check my third number, but without anything written on them. But if we think about it, you've got to go along the top to win 3 numbers, to win 3, to have 3 lucky numbers. So here it's just as we had 2 6 times 1/5 was the answer, which is 2 out of 30, which is 1/15 was your chance of winning with the 2 balls. Let's think of 3 balls. When I check my first ball, know there are 3 winning balls. out of the 6, and my chance of my first ball matching is 3 out of 6. Now, if my first ball has been a matching winning lucky ball, then there are 5 lucky balls left. My second ball, all right, my second ball, out of those, there are 5 balls there, out of which 2 are lucky, and my second ball has a 2 in 5 chance of being a winner.
And this sequence is 3 consecutive wins. Therefore, each time it goes down, and like if it goes vertically down the tree chart.
No, we're going across the tree.
That's what I'm saying. If you're going,
Caroline,
Tony, I'm differentiating between looking at the whole chart, that we are following the path of winning every time. Therefore,
so it's going there,
the number
there,
goes down.
there.
Every amount of possibilities goes down by 1 each time, because you've won 1. So there's only 1 less number to choose from.
So just as my chance of winning one of the top prizes, winning in the two game out of 6, was going along the top branches here. Can you see my cursor? In the 3 numbers game, I have to go along this top line again. Oh no, I didn't. Sorry, my cursor. Right, so I have go along the top line, and that's what these 3 numbers are. Okay, these are the probabilities of, as Caroline says, I have to win each time. The number of balls that I'm still trying to match with reduces from 6 to 5 to 4, and the number of that are left in the bag that are still lucky goes down from 3 to 2 to 1. So we multiply 3 over 6 times 2 over 5 times 1 over 4, and when we multiply that out, we get 1 in 20. Now then,
you get 6 over 120, and then you simplify to 1 over 20.
Exactly. So now we have seen a calculation based not on drawing this diagram, but on this reasoning, which we can generalize, we can apply when there's 1 more ball, so that we only need to do the same sort of calculation when there are 49 balls in the game, and it's going to be bigger numbers involved, but we're going to use again the same technique. But we imagine the tree diagram. That's the reasoning that we use. There's formal definitions in mathematics about conditional probabilities, which we might express it in those terms, but we're trying to make it quite simple and still correct. So why do this activity? What's the point of doing this today? What more our question is about is, if we're teachers, why would we do this in school? So there are 3 distinct learning objectives which we are going to talk about. Now, the first one is this question of being systematic, making an ordered list of all the possible sets of numbers that can be chosen in the game, and using that to work out the probability of winning. Now, being systematic is really an important transferable skill that applies in all sorts of circumstances, making sure that you've considered every possible case. It's not just in mathematics, it is in very many things that you do in your life. I mean, when you're doing some cooking, you're making a cake or something, it's the order in which you combine the ingredients is very important, and the order in which you do things is important. You have to be systematic to make sure you do everything right. Okay, so and often that's what a recipe is. It's a list of what you need to do and the order in which you need to do it. So somebody else has sorted out for you, but very often you are thinking for yourself how to be systematic. So we do this in school because we want to help learners to have skills that are going to be useful in life in very many more ways than just in the maths classroom or applying the maths. Now, we use tree diagrams to work out the probability of winning. And that's a powerful mathematical technique using tree diagrams. And we want to, for our learners, we want to give them the experience of working with tree diagrams in simple cases so that they can use the same technique for lots of different applications in probability. And it's important in business and commerce. We talked about insurance, and it's important also in many ways, not just in gambling. So tree diagrams are useful. And the activity can be used for different age groups. And for older learners, the teacher can combine both learning objectives. We saw simple versions of the game we can do with young children. And there's a few more answers to this why do the activity. Now, one thing they can do is play the game and collect data from the whole class and find an experimental estimate of the probability of winning. So that's an experiment. And they can work on calculating the true probability, either by systematically listing all the probabilities, which was objective 1, or using a tree diagram, learning objective 2. Now,
yeah, and that's a nice exercise. Do the experiment and then actually calculate the amount of possibilities, because we were using one or both of the weight methods of being systematic, because it also demonstrates beautifully the difference between real life, like you could throw 6 sixes in a row with a dice, it can happen, but the true probability is different. It's just that you have to throw it lots and lots and lots of times in order to get the average correct to actually
the thing about
correctly.
The thing about the experiment, as Caroline has said, is very often it's misleading. The results are misleading, and you have to have a large number of trials in order to be able to deduce anything with any degree of confidence from an experiment. Nevertheless, in the real world, there are many situations where the only way we have of working out the probabilities is experimentally. So, for example, medical trials, for whether a drug is going to be effective or a treatment. In the medical trials, they test thousands of cases, and some of them they get a placebo, isn't it? They get a tablet, but it's just
a placebo. It's just sugar or something.
Nothing, sugar or something. Yeah. And in others, they get the new drug, and they compare the results, but they have thousands of cases that they consider in order to draw any conclusion. And even then, you have to be very cautious. And of course, there are things like opinion polls and consumer surveys. And there again, you don't know for sure which way people are going to vote at the next election, which party, even though you may do an opinion poll.
People might lie to you.
Oh, exactly. So you have to carry out these experiments. They're experiments we're talking about thousands of times in order to get anything that's in any way reliable. And of course, statistics are behind when the actuaries work out the odds of the life insurance or home insurance or car insurance. You pay a premium, and then if you wreck your car, then you're going to be able to claim, and the insurance company works out the probability that you're going to make a claim, and you pay your premium accordingly. But of course, that's their calculation is based on statistics and in a sense on those are actually the results of lots of experiments, the data from lots of cases. So all those things are based on stochastic reasoning. What that means is they're based on experiment. And the probability. So, but the true probability
and weather prediction is also based on experiments.
Weather prediction, my goodness.
And this is all mathematicians. These are all people who did a degree in mathematics, and they're getting paid the big bucks because they're needed to control all these experiments and run all these experiments and make all these predictions as accurately as they can.
But that is experimental. But you can have a theoretical probability which will be true and absolutely certain. And this 1 in 15 and 1 in 20 that we were just showing you was definitely definitely a probability. So this problem that we've been working on, what it offers is a simple case of a lottery type game, and it helps learners to develop an understanding that they can build on to work out the probability of winning in the national lottery and to discover how little chance there is of winning, so that it's not worth losing money on gambling, basically. But if you are going to gamble, then you should know when to stop. So I'm going to just very briefly introduce this. We've got about 5 minutes. By the way, there's 1 in 14 million, one chance in 14 million that you would win on a lottery game where there are 49 balls.
So imagine you've got 14 million people. That's
14
not
million.
Yes, Tony. Imagine you've got 4. I just want to absolutely emphasize this point. If anybody wants to gamble, it's not 14 million. It's not 1 in 14 million. It's 14 million. If you can even imagine that number, well, I suppose because it's not big, because billion is.
So the other way of looking at it. So there's other ways of looking at it. That you'd have to play the game for millions of years, and you still might never win. And that's because of this small chance. So let's look at the Monty Hall problem.
The population of the world times 1,000, more than 1,000, like 2,000 times the whole population of the whole world. It's just, don't do it.
Mind blowing. Okay, so now, as I've introduced it, I'm just going to mention it, and there's a reference there to Wikipedia. And so there are 3 boxes, and 1 contains a car and 2 contains a goat. And obviously you want a car. So you choose door number 1, and one of the other doors.
Number 1.
Okay, and one of the other doors is open to reveal a goat. So, oh my goodness, it's not the car. So I still might have won the car with my choice of door 1. So, but you have the option to change your choice. You can now change to door 2, should you change.
So
now we haven't got
the answer. I know what the answer is, but I don't know why.
Well, let's think about the answer. Yes, you should change, because look, there are 3 possibilities. You choose before the door is open. There are 3 possible circumstances. One is that there's a goat in your box, in the one box that you've chosen. All right, behind door 1 there's a goat, and the goat's in one of the 3 boxes, so there's a 1/3 chance that it's behind the door you've chosen. You know that. And so with the first 2 possibilities, in this line and this line, there's a goat behind door 1, and with this line, there's a car behind door 1. Now, in this case, what you know is that what you see here is a diagram that you switch, and actually the car was in the other one, the one that wasn't opened, and you switch and you just win a goat. Oh no, wait a minute, what is this? No, that's the door that's been opened, so, and hasn't got the car in, so you switch to this door, because this is the door with a car, because you don't choose that one, that's the door that's open. You choose the one and you're going to win. And in this case, remember here that you're not going to choose the one that's got the goat in it. So you're going to choose this one, you switch to that one, and you win. So in 2 out of the 3 cases, you switch and you win. Now, in this case, there are 2 possibilities. The organizer might have opened one of this door, or the third door, or the second door. But in either case, the car's behind door 1, so you switch, you stay where you are and win. So if you stay where you are, you've got a 1/3 chance of winning, and if you switch, you've got a 2/3 chance of winning. So, at the start, the probability that box 1 contained a car was 1/3, and that doesn't change. But given the extra information, you know that the probability that box 2 contains the car is 2/3, and so you should change. Now, it's 6 o'clock, so we're going to stop. But just before we do, I'm going to pose this, which was sent to me from Matt Insel. When we put the lucky numbers and the Massland lottery, which has got 49 balls, when we put those up, Matt Insel sent us this, and it was a Monty Hall version of the lucky numbers game. So he said, supposing players choose 3 numbers from 6 and write them on a piece of paper, and a number is chosen randomly and is declared to be a losing number, players can change their choice of numbers, 3 numbers, and once you've decided whether to stay with the 3 numbers you chose originally or to change to 3 different numbers, the numbers are actually chosen randomly, and you must have 3 winning numbers to win, as with this game. And what's your chance of winning? So should you change or should you not change? So we'll talk a bit more about the Massland lottery, where the chance of winning is 1 in 14 million. We will talk about that in our next program, and we'll talk about the Monty Hall problem. So it's time to say goodbye.
I'm just been working on that thing, so I'm looking forward to understanding the goat problem, because I like it, and it's
You're in
I've
good
discovered.
Company.
I mean,
You're in good company, Caroline. Even really, really brainy people who are very, very, spend their lives doing mathematics, still find it tricky. It's a tricky problem.
Oh, I'm glad to hear that. But I'm at least I'm exercising my brain, and I'm growing my brain just by thinking about it. Thank you very much, everyone. See you
One more
next
thing,
week.
Caroline. We
Toni,
have
go
been
ahead.
telling people that we're going to do some more on teach pedagogy, different ways of teaching, which we will, and we are going to do some more on this, as we've just been telling you. So goodbye from us for now.
Thank you. Let's see if we can help people actually win some bets, or not, just not bets at all. Oh dear. Thank you very much.
Don't
See you
bet.
next time.
Don't
Don't
gamble.
bet. Don't gamble. Bye-bye.